All right, let's see how much of this review we can get through. This might just be the very first problem for this video. We're going to start with a free response question on our test. The free response questions are calculator allowed, and there's going to be one polar and one parametric. I put some more polar on here just because I think polar can be more challenging than parametric, so I wanted to practice that a bit more. So the figure above shows the graph of the polar curve r equals 1 minus 2 cosine theta for 0 to pi, and the unit circle r equals 1. It's a good idea to know where each curve starts and stops. It's not too hard to figure this one out. You can make a little table of points if you want to. But I just like to kind of verify, because the first thing we're doing, I should have said this, first thing we're doing is finding the area of the shaded region. So I need to know where, like the area is inside of the circle and outside of this curve. So I need to know where does this curve start and stop. So let's just see, if I plug in 0, I get 1 minus 2 times cosine of 0, which is 1, negative 1. So this curve, and there are no numbers on here, but this is going to be negative 1. That's going to be when theta equals 0. There we go. And then this one is probably pi. So let's just check that. If we plug in pi, 1 minus 2 times negative 1 gets me 3. Yeah, so face pi and go out 3. That's got to be theta equals pi. Now, I don't think I need the pi. I don't need the entire curve here, but that's good to know. And then this seems a whole lot like pi over 2, right? So let's check pi over 2. 1 minus 2 times cosine of pi over 2 is 0. Yeah, if you face pi over 2 and you go up 1, or forward 1, I should say, you'll be there. So this curve, when you start, you're starting here. So from the pole, from 0, 0, the first r goes here, and then it's going to come around and shade this way. And then it will come up, because I'm just on the spiral curve here, and shade like that. So I need to subtract this little section out from the circle. The circle is just like a 3/4, it's like pi r squared. R is 1. It's 3/4 of that. So I kind of know what this circle is. Like, here's the circle doing the same thing, here to here. And then the bounds are kind of different, right? Like, I want 3/4 of a circle that I want to subtract out of this. So in general, I want to say, what's the area I'm looking at? So I want to take this 3/4 of a circle, which I don't think I'm going to do calculus for on this. I think I'm just going to say that's 3/4 times pi r squared. And I want to subtract out, I do need calculus for this area, like whatever this weird little area was that does something like that. I want to subtract that out. All right, so I already said, like, yeah, I know what this one is. I don't think I need the bounds for the circle. I can just say the first area is 3/4 pi times 1 squared. And then I do need to subtract out the area of this polar curve. So remember, the formula is 1/2 times the integral from 0 to pi over 2 in this case of r squared, 1 minus 2 cosine theta, quantity squared, d theta. Remember, calculator is allowed, so do not go through the whole squaring this and getting everything and doing it the complicated way. I can just put this into my calculator and see what it comes out to. It's probably a nice number because I could do it without a calculator, but I'm not going to. So minus 1/2, math 9, 0 to pi over 2 of, making sure I'm in radian mode here, yes, parentheses 1 minus 2 cosine x, close the angle, close the big parentheses around r, square it, and then dx. Okay, I'm making sure that I have all that typed in correctly. Yeah, it comes out nicely to 2. If you're doing these, by the way, and my calculator's fast on the computer, but if yours has to think for a minute, that's okay. Just let it think. Some of mine really took a while when I did it with my handheld calculator. So, okay, so that's the area of the shaded figure. Now, part B says, find the slope of the line tangent to the polar curve at the point where x equals -2. Show computations that lead to your answer. So we're allowed to use a calculator. And again, I think when I first did this, I did the long formula for dy dx. But if you're allowed to use a calculator for slope, you're allowed to say, well, dy dx should be at x equals 2. I'll need to figure out that theta. It should be y prime of theta over x prime of theta. And remember, we have equations for x and y because y is equal to r sine theta. And x is equal to r cosine theta. And so r is 1 minus 2 cosine theta times the sine theta. And x would be 1 minus 2 cosine theta times the cosine theta. So I can have my calculator plug this in, but I do need to know what is the theta that gets us here. So I can say, all right, well, I need to know theta. So I can set my x equation, 1 minus 2 cosine theta times cosine theta, set that equal to -2. And I can solve this, excuse me, by graphing. So you should just be in function mode to solve by graphing. You can't do it in polar mode. Remember, the AP test is set up so that you don't have to switch modes at any time. So this is r times cosine. I want to know when it's equal to -2. What about my window here? So the x value, let's see. The thetas that we're plugging in need to be between 0 and pi, right? That's our domain. So I'm going to say, give me an x min of 0 and an x max of pi. And then I'm just going to have it zoom fit. So here's our intersection point. I'm going to keep this unrounded. Well, yeah, I'm going to write down the whole thing. So theta equals 2 because I just never know if I want to use it later. And you don't want to use rounded values. So now I know the theta. And yeah, I'm going to use it in a second, right? So I want to know dy dx for the slope. Dy dx at theta equals 2.466 ... is y prime of that number over x prime of that number. And I'm going to let the calculator do that. So you don't have to find r prime. You don't have to find x prime. You don't have to do this formula. Let me show you my first answer key. You could do all of this, but you really don't need to. I had to like type in this answer into this, and that got pretty ugly. So that was silly of me. Maybe I will repost my answer key. Okay, so I'm going to start with y prime. So math 8, I want the derivative of the equation for y. So typing this in, parentheses, 1 minus 2 cosine x times sine x. Evaluate that at 2 point, this is where I'm writing it, where I'm happy that I wrote down the whole thing, 2.466738. That's the y prime value. I'm going to do the same thing, and then I'll divide my two answers. So the x equation is 1 minus 2 cosine x times cosine x. Watch your parentheses with that, by the way. So here's r times sine, and here's r times cosine. 2.466738. Now I want y prime over x prime. And I get about, now I can round this, 0.473. We have the x coordinate. It's -2. We don't have the y coordinate. So what is y of 2.466 blah, 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 blah? So 1 minus 2 cosine of, I'm getting sick of typing this in. I probably could have stored it somewhere, but whatever. 7038 times the sine, because we're doing the y value. I'm getting that it is 1 point. Oh, I don't have to find the whole equation. Sorry. Find the slope. Don't find y of that. Okay, so what's the slope? It's right here. Ta-da. All right, that's much faster. I'm going to repost my key because that's much faster than doing it the other way. Okay, a particle moves along the polar curve, r equals 1 minus 2 cosine theta, so that d theta dt equals 2. Find the value of dr dt at theta equals 2 pi over 3, and interpret your answer in terms of the motion of the particle. So I'll talk about this. This is getting to be a more common question on the AP test. So first thing, they tell me d theta dt is 2, and I want dr dt. So I have an r equation. R equals 1 minus 2 cosine theta. So if I want to find dr dt, let's d dt both sides of the equation. Let's start there. Take the derivative with respect to t of both sides of this equation. That makes this dr dt. Take the derivative of this expression. So the derivative of 1 goes to 0. Negative 2 cosine becomes positive 2 sine theta. But you just took the derivative of a theta with respect to t, so you need a d theta dt. So this is a related rates problem. It tells me d theta dt equals 2. And we want to find dr dt at 2 pi over 3. So dr dt at theta equals 2 pi over 3. It should equal 2 times the sine of 2 pi over 3 times d theta dt is 2 no matter what. So it's 4 times sine of 2 pi over 3 is radical 3 over 2. You could also give the calculator version of this answer, whatever 2 radical 3 is as a decimal. Oh, I have it here. It's 3.464. Either one would be fine. Interpret your meaning. So we just did this in pre-calc today. I know we didn't spend a lot of time on it, so I'm going to refresh your memory here. What they're asking about this could be two things, so I always give two answers. Excuse me. If something's derivative is positive, it means that thing is increasing. So what did we just take the derivative of? R. So R is increasing at theta equals 2 pi over 3 because r prime of 2 pi over 3, actually, it's not quite r prime, is it? It is dr dt. Yeah. Because dr dt, r prime would be like, could mean like, r prime would just be like dr d theta. Anyway, because dr dt is greater than 0. So if something's derivative is greater than 0, that thing is increasing. What else could it mean? If r is positive and we know r is increasing, then we also know that if we were graphing this at, let's see, do we have this graphed? We do. At 2 pi over 3, here we are here, say it's right here. What's happening? The particle or whatever the curve is definitely getting farther from the origin the further you go out. And you can see that from the graph. But I could also say the curve is moving away from the origin because r of 2 pi over 3 is greater than 0. I can verify that by plugging it in, but I know that to be true because we're facing 2 pi over 3 and going forward to get onto this curve. So I'm just going to say it. And r is increasing. So anytime, think of it like velocity and acceleration. R is positive and increasing, so it's kind of like saying this thing is going to be shooting off even further from 0, 0. Okay, and then average distance from the origin. Average distance from the origin is just saying average r to a point on the polar curve for this interval. So this is a throwback way back to chapter 4. average value. So average value, our average, is 1 over b minus a, pi over 3 minus 0, times the integral from a to b of the function itself of r d theta. And r, I'm going to clean this up here, 1 over pi over 3 is 3 over pi. R is just the equation 1 minus 2 cosine theta, d theta. So we integrate r, and then we turn around and divide it by b minus a. That gives us the average r value again. All right, so what does this come out to? I'm just going to use my calculator. So 3 over pi times math 9, 0 to pi over 3 of 1 minus 2 cosine x dx. And I'm getting negative, if I round this, negative 0.654. What does this mean? From 0 to pi over 3, let's look at what that interval is. So 0, we're here, to pi over 3, say we're like roughly here. All of these r's are negative, right? You're facing 0, but you're going backwards, and same with all of those. You're facing quadrant 1 angles, but you're winding up back here in quadrant 3. There are a few positives here. But for a long time, and actually, I don't know if pi over 3 takes me to, pi over 3 takes me up here. Anyway, for most of the time, it makes sense that we would have an average r value that's a little bit negative, because you're at negative 1, and then you get some negative numbers here. You do get to 0, you do get some positives, but if I average out all those numbers, it makes sense to get a negative in this case. All right, I'm going to stop this video here. We'll just do a video for each for your response, and then a video for the multiple choice.